are going to be solving A-level biology question on the Weinberg equation. And I'm going to break down everything that you need to know about this equation. Now, before we solve this question on the board, what is the Weinberg equation? The Weinberg equation is used to calculate the predicted frequency of a genotype in a population. It is used to calculate the predicted frequency of an individual genotype in a population. Then what are the two equations that we are talking about? The first one is P plus Q equal to 1. Then the second one is P squared plus 2PQ plus Q squared equal to 1. Then what does P represent? What is P? P is the frequency of dominant allele. The frequency of dominant allele. While Q is the frequency of recessive allele. Q is the frequency of recessive allele. Then P square is the frequency of homozygous dominant allele. P square is the frequency of homozygous dominant alleles. So whereby the Q square is the frequency of homozygous recessive allele. Q square is the frequency of homozygous recessive alleles. So the last value there is 2PQ. What is 2PQ? 2PQ is the frequency of heterozygous allele. 2PQ represents the frequency of heterozygous alleles. So let's answer the question on the board. The question on the board says that in a population, 40% of butterflies are white. So those white butterflies are BB recessive. So they've given us the value for what? For the recessive. That is what? The frequency of homozygous recessive alleles. So the frequency of homozygous recessive alleles represents what? Q square. So Q square equal to 40%. Then 40% is the same thing as 40 divided by 100. So which is equal to 0.4. So we have gotten the value for Q square. So what is the question under it? The question says that what is the frequency of homozygous dominant individual? What is the frequency of homozygous dominant individual? Then which one represents the frequency of homozygous dominant individual? That is P square. P square is the frequency of homozygous dominant allele. So we are looking for the frequency of homozygous dominant individual. So that is what? That is P square. So P square equal to unknown. Then we have gotten the value of Q square. So from there we can get the value of Q. If Q square equal to 0.4, so what will be the value of Q? So Q will be equal to the square root of 0.4. So what is the square root of 0.4? That would be 0.632. So Q is equal to what? 0.632. Then we should not forget that we have P plus Q equal to 1. So we can get the value of P from the first equation. So if P plus Q equal to 1 and Q equal to 0.632, so P will be equal to 1 minus Q. So which is equal to 1 minus 0.632. So P will be equal to what? 1 minus 0.632 will give us 0.368. The value of P equal to is 0.368. Don't forget that we are looking for P square. P square is the frequency of homozygous dominant allele. So which is the same thing as the frequency of homozygous dominant individual. So we are looking for P square. So therefore, since we have gotten the value of P, so P square will be equal to 0.368 raised to power what? Raised to power 2. So P square will be equal to what? 0.368 raised to power 2 will give us 0.135. So therefore, the frequency of homozygous dominant individual is equal to 0.135.